Hello everyone, my name is Mayank Mendrata. I'm from Maria College of Engineering and Research Center. I'm assistant professor in civil engineering department. I hope you all are safe and at your home. As we all know, this is a very pandemic situation across the world, and offline classes are of course not possible. So I'm hereby want to deliver a lecture to our 6th sem civil engineering students on introduction to unsymmetrical bending. Before starting unsymmetrical bending, let us first discuss what is symmetrical bending. Uh, Symmetrical bending is somehow a thing that if on a plane there is a certain moment is applied, then plane of applied moment and plane of that deflection that is occurring due to moment should coincide, right? Or with the principal axis of inertia. Okay. So in this case, only symmetrical bending will occur. As we can see in this, the moment is acting on the axis of a plane on which that is coincides with the principal axis of inertia, right? So we will start with unsymmetrical bending now. Okay, what is unsymmetrical bending? The body which do not have symmetry in either x-axis or y-axis, right? Or sometimes in both. The bodies only having one axis of symmetry, right? Only having one axis of symmetry are having unsymmetrical bending, or that case might also occur when there is a condition of skew loading, right? Condition of loading occurs. So there are two cases on which unsymmetrical bending can occur. First, when there the symmetric axis, x axis and y axis are not present, right? And the second case is when there is skew loading, right? Okay, these are the skew loading of sections containing one axis of symmetry, as we can see in rectangular section, I section, channel section and T section. Okay, before starting unsymmetrical bending, first we have to discuss what is moment of inertia of an area. Actually, moment of inertia of an area is a misnomer, right? Moment of inertia of an area is a misnomer. Why? Because moment of inertia only occurs in body of field of dynamics, right? The body which contains three-dimensional axes, right? X, y, and z. So moment of inertia of an area is a misnomer, but for plane we will consider moment of inertia of an area as Ixx is equal to integration of y square dot dA. About that area, we have considered a small area that is at distance x and y, from axes, right? Okay, that we have discussed earlier in our previous syllabuses in engineering mechanics also. So moment of inertia of an area, if we have to consider Ixy, right, the about product of inertia, that is product of inertia, it can be positive and negative both, right? So first we have to know what is the moment of inertia of these common areas that are rectangle, right angle triangle, circle, semicircle. Like we can see, Ixy is 0 in a symmetric section, right? Rectangle section is a symmetric section in both axes, in x-axis and y-axis. But we can see right angle triangle is not symmetric in x-axis and y-axis both. So IXY have certain value here, right? In circle, it is symmetric to both x-axis and y-axis. That's why IXY is equal to 0. Right, in semicircle, it is only symmetric to one axis. That's why IXY is equal to 0. That is parallel axis theorem that we have discussed in our previous syllabuses also. But it will work out in this case also. In unsymmetrical bending, we have to know what is parallel axis theorem. So, okay, these are the transformation equation. Why transformation equation will occur? Actually, a plane is acting in x and y direction, right? So there is a certain centroid, right? There is a certain centroid on which moment of inertia is acting, right? The moment of inertia, say, is at distance x and y from this axis, right? Say this is somewhere moment of inertia, or this is centroid, and it is having x and y distance from axes, right? But this is not a principal axis, right? So xy can be transformed to a new set of coordinate, like we can name here x dash and y dash, which makes an angle theta with respect to original set, right? Like we have centroid here, right? So x dash and y dash, which makes an angle theta with respect to original set of coordinates. So these are the transformation equations that this x dash and y dash axis making an angle theta with the axis x and y, right? So we can derive the transformation equations from the previous Ixx and Iyy that we have calculated from the centroidal axis, that Ix dash x dash is equal to Ixx cos square theta Ixx cos square theta plus Iyy sin square theta minus Ixy sin 2 theta, and Iyy dash y dash is equal to Ixx sin square theta plus Iyy cos square theta plus Ixy sin 2 theta. Similarly, Ix dash y dash is equal to Ixx minus Iyy divided by 2 sin 2 theta plus Ixy cos 2 theta. Okay, these two axes x dash and y dash for which Ixy is equal to 0 are always called principal axis. Like when we are asking about symmetrical axes, there will be Ixy is equal to 0 always, right? In this case, because there is no axis of symmetry found in first case, so we have to transform our axes to the angle theta, and these are the transformation equations occurred due to this transformation to angle theta. By transforming these axes to angle theta, we will have finally Ixy is equal to 0. That Ixy is equal to 0 or is called principal axis, and this is axis of symmetry, right? This principal axis will always be a principal axis this principal axis will always be a axis of symmetry, right? And these also we have derived from this transformation equations. Tan 2 theta is equal to 2xy ixx minus iyy, and these are the normalized equation. Okay. After getting the transformation equations and angle theta, we will after that we will calculate bending stresses in that unsymmetrical sections, right? Bending stresses have certain equation. What is bending stress? Bending stress is sigma is equal to m upon I multiply by y, right? So when we calculate this, finally we will have this equation. Sigma is equal to m x1 divided by I x1 multiplied by y1 plus m y1 divided by I y1 multiplied by x1, right? So this is all with the introduction to unsymmetrical bending. We will also try to give you another class in which we will discuss a problem about unsymmetrical bending. Thank you. I'm signing off. My name is Mayank Mendiratta. I'm from Arya College of Engineering and Research Center, Department of Civil Engineering. Thank you, everyone.